I got to showcase Project Gamma to 4 of my YouTube friends, and the events that followed went way all over the place. So let's dive in and see how these YouTubers react to Hex Gen Redstone.
Hello.
Hello, how are you doing today?
I'm good.
There we go. Alright, now let me just TP you to me.
OMG, look at this target. What is my FOV?
I have no idea.
Hold on.
Alright.
My FOV is 70.
Alright, so this is what I've been working on. So there's this right here.
Which, OMG.
The smallest redstone computer in Minecraft. Now with turning
My
completeness.
My mouse! Okay, so how's this a computer? Me confused.
So, this is both Bedrock and Java compatible. So this can essentially...
And why did you build it on Bedrock?
Because I built all of these on Bedrock.
I'm crying.
So basically it has these functions right here, which can manipulate 2 numbers. And it also is Turing complete. So if you come over right here, you can see that there's a conditional right here. So basically, given enough memory, this thing can simulate just about anything.
What kind of memory? Where's the memory?
Well, that would have to be connected to this port right here. Like, I don't know if you've watched my channel at all. Like, I have built a hard drive. It could work. Flex custom tape moment. Alright, so I'm going to have to close the app and relog in. Because apparently the rest of my computer works just fine, but Minecraft does not.
Bedrock moment.
So,
how many gigafarts?
Gigafarts? It can do probably 69.
That's epic.
Yeah. I mean, if we're talking about computer speed, I'd probably say you could hook it up to like a 1 hertz clock or whatever and it'd run fine.
Hold on, I'm being called again.
Okay. Oh, he deafened himself this time, even better. Alright, you should be back. And you know what? Let me just go ahead and make you a member. I'm not giving you op status. Actually, wait.
Darn.
I'm like, that's too dangerous. Alright, so where were we?
I don't know.
Okay, so
make it computerized.
Computerized. Okay, so basically, short version, a computer is a device that computes. If you want to get even more technical, it's a person who computes. I mean, that was essentially what it was in the first place. So I'm going to use my handy little chart here to run some quick calculations. So let's see. Let's do the equation. How about like 1 plus 3? Does that sound fine?
That is an equation.
Alright, so I'm going to set this to... With this program, this is the instruction line, and this is the numerical line. So if we come over here, you will see that this has been set to the power of 1. I know you're a Java user, so you can't tell that immediately, but...
No F3, ew.
I know.
Ew.
But hey, at least I'm good at guessing signal strengths now.
Guessing.
I'll say that. Alright, so I'm going to set this one to 3. Now if you come over here, you can see that this register has been set to the value of 3.
Yes.
And then I can run this command, and this output is 5. What happened? Okay.
That's not 3 plus 1.
Guys,
his computer didn't work.
I know. Okay. What?
That's 5.
Oh! No, it's 4. It's 4. And you know why?
I see 5 lamps.
No, here, look. But if I break this...
Bruh.
I broke
Actually cringe. Actually cringe.
I know.
Just like, bruh. Let me fix your lamp display for a hot second here.
Okay. Hey, I will say, typically, I have it look like this, okay? Typically, I have it look like this. But, alright. So there. It's 4. Let me just break... Actually... You know what? I'm just going to do that and we'll call it good. Now, let's say we wanted to not that register, okay? So let's say we wanted to not 4. Well, we should get an output of 11. And then if I do that, then you can see the outputs should be 11.
Actually, 11/12.
You're right. 11
12
slash 12.
over 11. It's a fraction.
Let's call it good. And then, okay. So, I mean, I assume you can recognize at least some of these components. Namely, the
Maybe.
giant decoder over here.
Red coder.
Okay, you want to hear something so funny, though?
I want to hear.
Funny.
These top repeaters have to be set to 2-tick.
It's literally solid state. How would you need? Okay,
Alright,
I'm teaching you how your own computer works. Don't even know how your own computer works. CraftyMasterman has to tell you how it works.
CraftyMasterman insta to know how everything works. Crafty new jumbo.
Exactly. Now make it smaller. You can walk around it. Actually, cringe. Not small
Right.
enough.
Alright,
Now make it
so-
run Doom.
So this
Okay.
is what I consider to be a very primitive graphics card. And then it feeds into this serial display. So the the GPU uses a 1-wide serial transmitter to send a signal. So then I added this signal, which I'm calling a coil, which stands for Cool Optical Image Loader.
Wow, you have to put in
I know.
cool in there.
So let me just place down a checkerboard style, okay? Okay, so if all goes well, I've just programmed a checkerboard. So now if I send this, it will send the serial display like so.
Nice checkerboard.
And I messed up the checkerboard completely. Of course I did.
Nice checkerboard. All being recorded, guys.
So you know what? I'm just going to wipe the screen. And then I'm going to see if I can draw dude waving. So now you should be able to see this change into a dude waving. Of course,
Nice
this isn't
dude
working.
waving. Actually, it's a smiley face. Just like in post, just edit yourself saying,
Right.
I'm going to make a smiley face.
Right, just make it like absolutely obvious that this was not what I intended it to be.
Oh my god, I'm being called for the 3rd time. I'll be right back.
I then spent a couple minutes trying to figure out why it wouldn't work. I also trapped Crafty in a bedrock cage and then completely forgot about it until he got back online. Go.
I'm in bedrock.
Let's go.
Oh, look, you got to put signs now. Nice checkerboard. Oh,
There we go! Finally, a checkerboard.
guys, he made a checkerboard. Wow.
The final thing I'm going to show you today is this little thing right here. There's this little
God,
thing
it's
over
so
here.
small, it
and this
has
little
to
thing over
work.
here. It has to work. So I'm calling this the far distance analog transmitter / receiver system. Basically the or
OMG.
aka the FDAR system.
Okay.
So if I wanted to say send a value of 1 down this line, I'd run it. And as you can see, these repeaters come along and it outputs a 1 over here. See? This one works the first time.
Oh my god, insane. Wow.
So what'd you think? What would you give it a rating?
I like this the most because it worked first
It
time.
worked the first time.
Well, everything worked perfectly for the other YouTubers, so maybe I'm not the problem, Crafty.
Well, how do I rate this? How do I rate? You thought it was a 10? No, we're not done yet. Are you monetized?
No.
Okay,
Why does that affect the rating?
there we go. That's the rating.
Alright, so this is the RPC-3, the smallest resident computer in Minecraft. Total dimensions are 8x12x3.
Pretty small, dude.
Yeah, more or less the same functions as the RPC-1, but it has a conditional, so it is now Turing complete.
Oh, there you go.
The main difference I really like is this right here. So I've never really been able to get a good output port working, but with this design, you can easily just output whatever off of the input line.
Yeah, makes sense.
Yeah, we can set register 2 to the value of 1, so if we head over here, this now has value 1 on it,
Oh, I see.
Then I'll go set register 1 to a power of 4. So that would be this and this. So now register 1 should show a 4.
Yeah, I see it.
And then, let's see, 3 is add, and so we can add them together, and we get an output of 5.
Nice.
And then, let's say we wanted to not that, so let me set register 1 again. So that would be this. Then we should be able to get a 10.
Yep.
Yep.
I got 10.
And then the last function is the conditional, and that would be if A is equal to 0. Currently, A is being stored with a value of 5, so the conditional is off right here.
Oh, yep. The torque.
So,
Yeah,
but
I mean, pretty nice job.
Yeah, I definitely took advantage of some features. So like right here, like in previous models, I had a system that looked like that. But I was like, well, if we just need it to power, then we could have something like this, and we'll still do the same thing.
Oh, yeah.
So like, for example, if I wanted to...
And then you can reuse, like, if you had it like this, then you could reuse the block for something else.
Yeah, if I wanted to, or I could just have it like that and keep it within a 2x2 instead of a,
Yeah.
2x3 or whatever. So then the other thing that is Java compatible is what I call the far distance analog receiver and transmitter system, or as I like to call it, the FDAR-FDAT system, because FDAT. So how this works is it takes an analog input and then flashes it into a signal strength. So I'm not sure if you've seen this before. Pulse length. Sorry, not pulse strength, pulse length. So let's say I wanted to do a... Let me just grab an item frame real quick. So if I place this
I have
down-
seen this before, actually.
So let's say I
Yeah.
wanted to send an 8. I can flash this, and it'll send the length down, and we'll come out with an 8. Except this is a 15 because I forgot
Yeah,
to reset this.
Reset it, yeah.
Yes,
Reset
this
it,
is a
reset it.
prototype. I don't have any way of erasing it, but I was doing this more of a prototype for people who want to, say, create like a network card.
Mhm.
So like a internet card or whatever. Like this system would be great for that.
Yeah, I mean, it takes a little bit of time. You have to
Yeah, it
wait.
takes a max of 3 seconds to create it into a pulse length, just depending on the length. So it takes 2 ticks for if you want to send a 1 and 3 seconds if you want to send a 15. But I mean, after that, you're as
Okay.
fast as repeater check.
Mm.
So this is what I'm calling the Render Dragon 101, and this is what I'm calling the Cool Optical Image Loader display. So what this is this would be a very, very, very primitive bitmap hex graphics card. So basically, it's a hex signal to pixel correlation. It doesn't make like a perfect match. So like your bottom, so like let me just show you, like it doesn't go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or whatever, but it does have its own order because it goes like 1, 2, 3, 4, 5, 6, 7, 8.
Oh,
9,
that's
10.
weird.
It is weird.
Wait, why does it do that?
It's because of how this one-tick serial display works. So if you look at how the repeaters are facing, it runs along this way and then runs along the top.
So it's constantly changing from the top row to the bottom row.
Yeah, so the bottom row gets fed up to the top, and then the top runs out to this repeater.
Yeah,
This repeater right
I
here gets
see.
sent along the line.
I kind of want to make one now.
Yeah, I mean, go ahead. You can see that this smiley face blinks and then comes out with a new smiley face.
Oh.
So what that allows you to do is to create animations with a serial display. So it's not just pixel displays, it's a serial display that can display
Yeah.
animations.
I mean, it's just gonna have a really low frame rate, but yeah.
I mean, this is Redstone. Come on.
Well, but more importantly, it's serial, right? I mean, anytime you're
Yeah,
doing
like-
serial versus parallel, it's gonna have a lower frame rate.
All right. So how would you rate this system? Just out of curiosity.
Out of what?
Well, Crafty did out of 10. So
Crafty did out of 10.
Crafty did out of 10.
Kind of wish I knew what Crafty said, but
You know what? Let me just pull that up real quick and show you.
all right. In that case, I'm gonna give it a longer one out of 10.
A longer one, okay.
But like still noticeable, so that you know that it's longer than Crafty's, but like not by that much.
Hello. It's pretty funny.
Labster's Alex skin confirmed.
You're gonna have to explain everything.
Okay, so this is the RPC-3, the world's smallest redstone computer.
Oh.
And
Okay.
it's now Turing complete, if you know what that means.
I don't.
Okay, so basically it means that given enough memory, this thing can simulate anything. But yeah, it's 8 by 12 by 3.
Tiny.
And as you can see, there's no binary in it. So it's a hexadecimal PC. So essentially, it's the equivalent to a 4-bit binary PC.
What's that?
Okay, so what?
What is? I don't really know. What is what like?
So I'm going to set this. So as you can see, this register right here has been saved to a value of 1. No, you cannot F3 it. But it's saved.
Oh, right here?
Yes, so that's now saved. And then
Oh, wow.
if I were to
Okay.
go right... My mouse is glitching. If I were to go right here and set this to do 3. Now this register over here is set to 3.
Oh, wow. Wait, okay.
And then, if I were to add the two together, which would be this... That's the wrong command. This command, you can see the output's 4.
How did you do that? I think I crashed. How do you remember what each of these thingies do?
Okay, so I have a document on one of my other monitors that basically tells me what each of the functions is. Either that, or I literally just run along this, figure out what command I'm sending, and then look at it from there. Like, let's say...
Oh my gosh.
1 plus 1 is 2.
Oh my gosh,
1 plus 2 is
what?
3. 2 plus
Hold
2
on,
is
I need to
3.
screenshot this. This is useful for everything. I like this a lot. If I was to... Let me get a lever. If I was to do this, it would be like... the opposite! Oh my gosh, no way. No way. This is insane. And why am I not smart like this? Like...
I have no idea.
Oh, yeah, okay, you could have been like, no, you are, no, I have no
no
idea. Wow.
So, this is my first primitive hex graphics card.
You said primitive.
So, it's gonna be primitive.
I love
So
primitives.
So
I like this.
So have you seen serial displays?
Yes, actually, now that I remember it, there was this YouTuber I saw. Oh, I forgot his name. It was like I forgot his name. Computational person. Yes, him.
Yes. Okay. So there's a lot of serial
Are you
displays.
like best friends with him or something? You're best friends with him, right?
Unfortunately,
Just say
no,
yes. So I feel cool. Just
Okay,
say.
And then we have a checkerboard.
Oh, checkerboard.
Now, if it was a typical serial display, the entire screen would go white, and then you see your smiley face. However, this
But yours is special.
Boom.
It's so good.
So, theoretically, you could have this of a man waving, or even Pac-Man in Minecraft if you were able to code it enough. So I'm calling this the Far Distance Analog Receiver / Transmitter System, or the FDAR-FDAT system. Because I agree. FDAT.
I agree.
So what this does is it takes a hex input and converts it into what's called a pulse strength, or a pulse length signal. So
wait, actually? Oh my goodness. I need to screenshot this. Wait, I keep screenshotting things in my clip. Okay, whatever. Continue.
Okay, so this takes a maximum of
Go
3
ahead.
ticks, okay? So let's say we want to send an 8. I flash this, and as you can see, it sends a length all the way over to the F-dar. So that's the F-dat, this is the F-dar over here.
Where's it go? Oh!
And as you
Wait.
can see, it's
How
an 8.
was that with signal length?
Yeah, so this is with signal length. So like, let's say we wanted to send a 15. Also, this is a very prototype piece, so you can't erase this with like a program or anything. I've built this so that people could build like their own networks. So like you could create like
I
internet
erased
and
this.
something with this.
Oh, I see.
So,
I erased with piston.
Yeah. So let's say we wanted to send a 15. We flash it, and as you can see, this takes a really long time to send.
Oh my gosh.
Whereas if we
So
send,
fascinating.
say, a 1, it's lightning fast. We just broke it.
Oh.
As you can see, a 1 gets saved.
That was fast. I like this. And I actually like this is very useful. This is very educational and I love it.
Okay, so now which of these is your
Edu-
favorite?
Probably the one with the smiley face.
The
Sound like a
coil?
2-year-old, I don't care.
Alright, and then, okay,
Oh, that's how this thing works. I love this. This is like everything I always wanted to
I'm sorry.
make and then overcomplicated it. What do these drop? Oh, you're locking the item. That
Yeah.
would be... Oh, okay.
Out of 10, what would you rate this?
I would rate a 9 only because I don't understand some parts and that's my fault for being dumb. But everything is so clean and everything I want except big. I mean, except small and I do big.
Smaller. Alright, can you hear me?
Nope.
Okay, perfect.
Chen. Ah.
So, this is my latest Redstone projects. Yeah, so this is the command lines, this is a function, this is data, and then this right down here is data out, and this is function out.
I was gonna ask, what are your 6 functions that you got here? Obviously, one is
So,
what?
this is a set register 2, this one wipes the output register, this adds register 1 and register 2 together, this sets register 1, this one wipes register 1 and register 2, and this one knots register 1. So if you look, register 1 just got knotted.
So then what you could probably do if you have this function overflow here is you could feed this back into a sequencer unit, and then just have that connect to both your function output and your flag. You could probably create a very simple sequencer. You wouldn't be able to branch based on indexes, but yeah, very simple
Gotcha.
branching could be achieved.
Yeah. So I mean, there's not a lot given enough memory, this could simulate a lot, but
Well,
yeah.
any computer given enough
I mean,
memory.
and, yeah, given enough memory, anything can simulate anything.
That's still pretty cool.
Yeah.
I could see then like the majority of the space for something like this being used for your program memory and function memory, I guess.
Yeah. Program memory I've had a hard time with because, I mean, just to store a couple bytes would take probably something 4 times this size, like just to be able to easily run a program. I'm still working on trying to figure out a good program memory, but currently I have it set up to where it can be programmed. I want everything to be fast per se, and also size. Like, I'm a size guy for some reason. And so
Remember, kids, size doesn't matter.
size does not matter unless you're trying to go for a record. I mean, there's space. Like you can walk around in here, so there's space to get smaller. I don't
But
know
the question is, like, can you actually pack something in here? Because that was one of the
Yeah.
issues that I ran into with like Deep Thought myself.
Deep
Was there was
Thought.
definitely space for more, but there
Yeah.
wasn't much that I could really, throw in there. Particularly with hex logic, because obviously you have to refresh your signals quite often to maintain the value
This-
going through
yeah.
the computer. So There's a lot more than just redstone dust that you're dealing with here.
Mm-hmm. Yeah, it's slow, but it's like this is 4 bits, and binary can't get this small. Like, I highly doubt anyone could get a binary computer this small.
Absolutely not.
And
you know,
and have it be 4-bit. I mean, if it's 1-bit, yeah, it's possible, but like 4-bit, no.
yeah, but there's not much you can do with 1 bit now, is there?
No, I mean, if you want to make a clock,
I mean, if
hey,
yeah.
give it enough memory, a 1-bit computer can simulate anything.
Well, I suppose you're not. I mean, you're not wrong. The Turing machine was a 1-bit computer anyway.
True.
We're gonna get a lot of hateful comments over that one.
And it's like, yeah, it's like that's a really common misperception that they have to be Turing complete. Now, it is incredibly helpful, but it's not necessary per se.
Like I said, you're gonna get a lot of hateful comments for that one too.
Whatever.
Don't mess with the geek's definition.
Yeah.
As far as like hex computers are concerned, I mean, I think this is the farthest anybody's ever gotten with this sort of tech. Well, I was gonna say I've seen hex tech before, but nothing quite like, you know, with actual registers and
Yeah.
flag and branching and all this stuff. One of the things that I would have really still would like to see is somebody building like a practical application for a computer in Minecraft in survival.
Yeah.
But I mean, even my smallest computer was still too big to actually be deemed practical.
Yeah,
this
'cause
one
it's
I
like-
think is
It is
For- yeah.
practical. I mean, I built one larger than this in a pure survival world. And this one's smaller than that one. So I mean, it is practical. I mean, when you're talking about redstone computers, they're not really survival practical. But
no, there's not a lot of applications, but I think
Yeah.
as far as accessibility is concerned, this one's a lot easier to achieve in survival
Yeah.
than. Yeah, but I mean, imagine what you could do with like something like this controlling a base. You could actually have
right.
like configurable, programmable logic. Like
Mhm.
I don't know, maybe somebody out there can like download this and see what they can do with it, just for S's and G's. The dropper, hopper, rafflecopter. Throwback if anybody recognizes that.
So like, let's say we wanted to draw a smiley face. So that would be. Let me just
Oh,
go
he's
ahead
got this planned out, doesn't he?
Yes, I do.
Oh, so you can actually just hold your set pixel command and just
Yeah,
select
so
the
you can-
pixels.
So yes,
Oh, there you go.
there we go. So you saw that little flash.
Yep, so that was
Yes,
the
so
frame
that's
refreshing.
Yeah, that's that frame refreshing. Typically, this would all turn on, and then 1.5 ticks later, the new display would come up.
I can see Wilson 2.0 coming to existence real quick here. Oh wait, that's another Etho reference.
So this I call the FDAR system. So the far distance analog receiver / transmitter system.
Oh, this was your PWM system that you were showing, wasn't it?
The pulse length
Pulse
system.
width, yeah.
Yeah, the pulse width. Yes.
Yeah, I came up with something like this years ago, but this is a lot more elegant. Mine actually had like oscillators and comparators.
Yes.
And it's just-
So for example, if I wanted to say send a 3, it would load that. It takes 2 ticks per hex value. So if it's 15,
Yeah.
it takes 30 ticks. If it's a 1, it takes 2 ticks.
So I think the reason why yours is so much smaller than mine is I was actually the way I went for it was trying to emulate actual pulse width modulation where the frequency
Yeah.
remained constant. Whereas yours, you actually have a variable frequency. So the shorter your value, the shorter the pulse.
Yeah.
And that of course works too. In fact, it's probably a lot better at. Obviously, it's a lot better.
Especially for Minecraft. I mean, you need to optimize a lot of stuff for Minecraft. So basically, it goes
Yeah.
on repeater tech.
Repeater tech. Very simple, very elegant. I like it.
All right. So out of
Recording again.
10, what would you rate it?
10. I
So-
would say it depends how you look at it. If we're talking like taking on the challenge, like constraining yourself and seeing what you could do, I would definitely say like 9 or 10.
Alright.
If we're talking usefulness, I would say maybe like a 7, depending on your aspect or context. But overall impressions, I would say like an 8 or 9.
That is YouTubers reacting to HexGen Redstone. If you want to check these channels out, their links will be in the description below. If you want access to the amazing builds that you saw in today's video, that will also be in the description below or on my website at ct5k.com. Or you could just click on this video. Anyways, that's it for today. I'm CT5K, and I'll see you in the next one.